Welcome to the podcast for Healing Neurology, where we talk about everything that can help heal your neurology, which is really everything from food, lifestyle, and medicine to nature, culture, and politics. There's no topic too big or too small. I'm Jillian Ehrlich, family nurse practitioner, certified in Ayurveda and functional medicine. And we have here with us today the illustrious Dr. Ilene Ruhoy.
Hello.
Hello. Board certified neurologist, PhD in environmental toxicology, and founder of Center for Healing Neurology. Dr. Ruhoy also has done integrative medicine fellowship with Dr. Andrew Weil and the University of Arizona. She also has specialty training in mitochondrial medicine, and she's did a fellowship in neuromuscular medicine. Dr. Ruhoy, welcome.
I'm happy to be here.
I feel the same. And I'm excited about our topic today because it's a topic that I think doesn't get enough airtime with most clinicians and should actually be part of primary care, even down to that level, because we're going to talk about mitochondria and we're going to talk about what they are, what they do, what goes wrong with them, and how we treat them.
Yeah, I actually disagree with what you said. I think that mitochondria does get a lot of airtime these days. I think it's a word that's sort of batted about amongst a lot of different healthcare providers. I think it's sort of the new trend of what we need to think about and address. But I think what should be further explored is more of what you do and how you think about the mitochondria and how you approach them and what they actually do and how you can help support them.
Let's start from the beginning. What the heck are
briefly,
mitochondria?
Mitochondria are these organelles that are present in every one of our cells, and in organs that are very metabolically active will have lots more mitochondria than organs that are not as metabolically active. So, for example, our brains and our muscles and our heart have quite a few mitochondria, thousands in each cell. And so the mitochondria, of course, provide the energy for the cell, and they do that via oxidative phosphorylation of the electron transport chain, which has 5 complex enzymes. And so, it's like any other chain. If one of the, links in that chain aren't as strong, that entire chain isn't strong. And so it applies as well to the different enzyme complexes along the respiratory chain complex, or otherwise known as the electron transport chain. And so at the very end of that chain is where the energy molecule of ATP is produced, and that energy molecule is used in all of the many biochemical and enzymatic processes that take place intracellularly, extracellularly. And so our entire physiology really relies upon the health of our mitochondria.
What we're talking about essentially is food comes in through our mouth, gets uptaken through our GI tract, and then those raw building block materials are broken down into this common substrate of acetyl-CoA, and then that goes into this mitochondria, and that's how we make our energy.
Right. I mean, that's a piece of the puzzle. I think a true conversation of the physiology of mitochondria is likely outside of the scope of this particular podcast. But yes, obviously the health of the mitochondria does, in many ways, rely on the health of the foodstuffs that we consume. So that's sort of where the building blocks come from. It's also where the cofactors and substrates come from. Every enzyme reaction has its own cofactors and its own substrates. And so it really does depend upon, as you very adeptly put it, the building blocks, right? So the building blocks will affect how efficient and effective the enzymes of the mitochondria are. So it is very reliant upon lots of things, but definitely the foods that we choose to eat. And the lifestyle we choose. Don't forget, the mitochondria can be affected by stress, right? So, or any kind of exposure, because that's a burden to the mitochondria. They have to work extra hard to sort of counteract that stress on the body. So a lot of what we do on a daily basis can really affect the function of our mitochondria.
In addition to the food we eat or the quality of the food, especially the micronutrients that can be those substrates for enzymatic reactions, what are some of the other things that we can do in our lives to ensure our mitochondria stay healthy and strong and numerous?
I know you said except for food, but the food is really very important. Nutrition and our dietary choices really do make up the building blocks of our entire bodies and down to a microscopic level of the cells and its organelles, including the mitochondria. So I do think it's important that we at least focus on the foundations of health that we always talk about here in clinic. And there's reasons why we preach that, because it really does at least set the body up for success. Like, is it completely curative of everything? Of course not. Will it ensure that you don't get sick? Of course not. But it does set the body up for success. It gives a milieu where at least healing could potentially take place. And so we do know that the vast array of fruits and vegetables that are available from Mother Earth have lots of the compounds that are actually very, very important. A lot of antioxidants and anti-inflammatory compounds that really really help to sort of, reduce the level of oxidative stress on our cellular machinery are present in these fruits and vegetables and some other earth-based foods like legumes and so on, and nuts and seeds. So I think that we do need to focus on our diet, but we also need to focus on sleep, obviously, is very important. Restorative sleep is very important. Movement on a daily basis. We talk about how it doesn't have to be triathlons. Like, people just need to not be couch potatoes, and especially if you have a desk job and sit a lot, you have to get up and move, and preferably get up and move outdoors, because we do know from studies that nature has a very healing effect on our mitochondria and our cells and our just overall well-being. So even just going for walks and getting out and getting some sun and being amongst, different nature settings and different landscapes all have various very healthy qualities that, again, just sort of set up the right milieu for our body to really harness its own healing powers when it can. And so all those things are obviously just sort of the foundations of health. But, these days I think that we have to be cognizant of the fact that we have lots of exposures, and there's various kinds, and, we can go into depth on another podcast perhaps. But obviously, we're, especially now in the time of the pandemic, clearly we're all aware that we're very much vulnerable to infectious organisms, be that viruses, bacterium, fungi, and so on. So those are exposures. There's lots of different chemical exposures in our environment. Some we can control, some we can't as much. And certainly in the products that we use and in the things that we come into contact with, there's always, certain kinds of environmental exposures. In our water, my dissertation was, water sampling studies that show that there were pharmaceutical residues in our waterways. And so, and there were literally, tens of pharmaceutical residues that I found that ranged from antibiotics to, antihypertensives to, like the opiates and so on. And so our water is, could potentially have contaminants in it that affect our mitochondrial burden. There's, of course, a lot of mold in certain particular climates of the country and of the world. And, so I think that we have to be cognizant of sort of what we're coming into contact with, even if it's invisible, even if we don't see it, because it does have this effect on our physiology. And so, and all of that is important because it's the mitochondria's job to sort of keep those cells healthy. And when it perceives a danger, and we always talk about the cell danger response, when it perceives that danger, it does alter its level of oxidative phosphorylation, which can, chronically can certainly have detrimental effects to the cell and its function. Now, I think that's a whole topic in and of itself. And what I do want to talk about, which I sort of already touched upon, is the importance of the mitochondria to its cell, and then by extension to the organ in which that cell resides, because cells have a function and work with other cells to perform the function of a particular organ, whether it's a brain cell, a liver cell, a kidney cell, a muscle cell, and so on. And so I think what's interesting in terms of some recent research is that we do know that stem cells, one of the ways in which they work, one of their mechanisms of action is that they actually transfer mitochondria to damaged and healing cells by forming these nanotubules, basically. They connect a tunnel from the stem cell to the damaged and injured cell, and it actually transfers whole mitochondria, which is interesting because the stem cell remains in a dormant state until it's sort of induced to differentiate. So it's in a state of glycolysis. So oxidative phosphorylation is not taking place. So in other words, those mitochondria are basically, unused equipment. So they're not yet privy to the oxidative stress that can sometimes happen to an active working mitochondria. And so when those stem cells are liberated and start to perceive signals of that sort of induce them to differentiate, upon differentiation is when oxidative phosphorylation is then started. And so then the stem cells will migrate to where the healing and damaged cell is and will then transfer their mitochondria over, which I actually find completely fascinating.
That is amazing.
Yeah, when I started to read about that, I recognized that our bodies are way smarter than we even give it credit for.
If we would just get out of their way.
I know, exactly. If we would just get out of their way, which we never do,
No,
right?
we never
because
do.
we choose to do things that are more harmful, I think, at times than beneficial to our bodies.
Stem cells, we don't typically talk about them as a program for like mitochondrial recovery. We talk about them for what?
Well, we talk about them for regeneration.
Regeneration.
Right, for regeneration. It's a part of, I think, regenerative medicine, but I think initially that was applied to more like anti-aging kinds of purposes, which it could definitely be applied to. But I think more and more research is showing that it can actually help regenerate degeneration, so any kind of degenerative type disease, and that doesn't necessarily have to be only in neurology. Every organ system can have some disease that causes, premature degeneration. Obviously, as we age, that's some form of degeneration, but certain diseases have a more rapid pace of the degeneration. It doesn't, like I said, doesn't have to be specifically in neurology. But so I think that now regenerative medicine the research at least is being more applied to degenerative kind of processes and not just the natural aging process. And so that's what's fascinating. I think it holds the potential to really have remarkable effects in the world of medicine to treat some diseases that have been notoriously difficult to find a lot of effective or at least sustainable treatments for them.
Some of those, just for listeners at home, if they are wondering if kind of things that they have might be appropriate for stem cells, can you just kind of name off some of the
Well, I think I know in the research world, specifically in neurology and in some other specialties, I've seen research with regards to the benefits of stem cells for, things like ALS and MS. I've definitely seen it for a lot of autoimmune disorders. I've seen research actually for diabetes in terms of regeneration of some of the beta islet cells of the pancreas. Research with regards to obviously arthritis, so certain rheumatologic diseases, so joint injections of stem cells have shown to be very beneficial. Pain has been treated with stem cells. So the research really just sort of covers a wide array of different disease processes.
Cognitive decline.
Cognitive decline, right? There's actually quite a bit of research on Alzheimer's and TBI actually. So there was research with more recently, I think that where they did intraventricular injections of stem cells for Alzheimer's patients, and it had a positive outcome. And so you can definitely do stem cells for cognitive impairment and TBI. We do a lot of mitochondrial medicine. And just to be clear, obviously, it's not all about stem cells. I mean, we do a lot of mitochondrial support because the cofactors and the substrates that I refer to really are nothing but vitamins, ultimately. And so how we get them and how we utilize them, and I think is a large focus of what we try to do with patients with any kind of mitochondrial disorder. And, historically, or even today, when there's a true mitochondrial disease that often will present in childhood, the mitochondrial cocktail is still very popularly used, which consists of several different types of supplements that are just sort of, as I said, part of the cofactor and substrate list of the mitochondrial enzymatic chain. And so that's a lot of what we do. We try to sort of guide people at least on just sort of supporting their own mitochondria. And of course, we do the functional assays with the MitoSwab kit to sort of look at the functionality of each of the enzymes, except for enzyme 5, but of 1, 2, 3, and 4 complexes to sort of see at what capacity are they working at, and which is an easy test to do because it's just a buccal swab. And actually, we're starting that study to sort of combine the MitoSwab and the VASPR technology, which we love for mitochondria. There's a lot of research, and I'm looking forward to sort of contributing to it, make a more robust body of knowledge with regards to VASPR technology and its effect on mitochondria, because VASPR sort of utilizes the beneficial effects that we know about with regards to compression, as well as to hypothermia, combined with a low-intensity type exercise, which actually helps to enhance blood delivery as well as, importantly, blood perfusion, but also has been shown to help increase, certain anabolic compounds and anti-inflammatory compounds. And so it's also been shown to really help improve mitochondrial function, and we're going to sort of test that a little bit in our clinic with an upcoming study, and we're going to do pre and post MitoSwab studies to sort of see the functional capacity of the different enzymatic complexes, pre-sessions of VASPR and post-sessions of VASPR. So that'll be real exciting to sort of see what happens with that, and I do expect it to have a positive effect on our mitochondrial activity.
Can we talk a little bit more about the MitoSwab? That is a test that we offer in our clinic, so we can drop ship it. Can you talk about, so buccal meaning cheek, so it's just a little like Q-tip you put on the inside of your cheek and then you put it into an envelope, send it in the mail. When we get the results back, what are we looking at specifically and what can we do about each of those results?
So it does test the functionality of 4 of the complexes, so complex 1, 2, 3, and 4, and it gives you a percentage of activity. So it sort of shows you, so even if you're in the normal range, you can actually even measure improvement. So for the VASPR study that I was referring to, even if you have normal functioning complex 1, for example, because it's reported in a percentile, you could actually show improvement of that complex's activity. And so it shows how each of those complexes are functioning. And it's important to understand because it can sometimes tailor how you treat. I mean, so as opposed to putting, for example, someone on the entire cocktail of supplements, you might not have to because each of the complexes has its own sort of unique fingerprint, if you will. And And so then you can tailor it a little bit and you sort of have something that you can monitor and measure. I will say that, we know a lot about the complexes and how they work, but in terms of how to correct one complex deficit versus another, it's a little bit more complex. And I think the research is still sort of up and coming to really speak definitively on that. But we do know quite a bit of what we are exposed to in our lives do affect that chain, affect at least one of those enzymes. And sometimes one of the enzymes will compensate for another enzyme. And so we can actually see that pattern on the mitoswab, which is useful. And actually one of the papers that I'm involved in is talking about gadolinium exposure and its effect on mitochondria. And so we have found with patients who have had contrasted imaging that the heavy metal of gadolinium, that when it's retained and not excreted as efficiently as we expect it to be, for those patients there can be detrimental effects to the mitochondria. And so, when we see on the mitoswab that there's deficits in some of the enzymes, we can actually sort of maybe take a more pointed history, I think, on what this patient's potential exposures have been, are currently, might be in the future, and really try to work with an individualized, personalized plan to really help support the mitochondria. Even adverse childhood events has been shown to have effects on the mitochondria, and that goes back to the cell danger response, which we really should talk about one day, but we should get Dr. Bob Navio on a podcast because this is really his area and he coined the term cell danger response. But, adverse childhood events have been shown to have effects on the mitochondria, as are, infectious exposures and concussions and TBIs and so on. So I think that what I like about it is that I get a look at the functionality of the electron transport chain, and then I can look at the patient directly in their eyes and say, tell me more about you. Tell me why your mitochondria aren't working as efficiently as they are. And you can go as far as like looking for, doing mitochondrial DNA genome analysis or nuclear DNA analysis, because some of the nuclear DNA does control some of the proteins that are synthesized for the mitochondrial, not only the electron transport chain, but some of the parts of the mitochondria. So it can have a detrimental effect on the mitochondria itself. So it's not necessarily mitochondrial DNA mutation that could be causing the deficit, but it could be something from the nuclear DNA. So we could go as far as doing like genomic analysis to sort of see if we can identify a variant that might affect how the mitochondria work. But oftentimes you don't find a mutation. I mean, usually mutations, like I said, are present in childhood and they're sort of discrete diseases and disease processes. But I think what we do a lot here in this clinic is just sort of see the effects of other things on the mitochondria and the burden that they take on and how they start to sort of slow down and become dysfunctional, which has then adverse effects on the rest of the physiology. And so I like the idea that we can sort of see the functionality of the mitochondria and then speak to that person specifically and understand, what's happened in their lives, what they've been exposed to, how best we can help them avoid further burden on their mitochondria.
Historically, mitochondrial medicine has been a pediatric specialty.
Correct.
Why is that?
Well, I think that first sort of came on the scene, if you will, because mitochondria, they have retained their own mitochondrial DNA. They used to be an organism, and then they sort of created this symbiotic relationship with us. And so we sort of envelope them into our cells. So they were their own organism, and they had their own DNA. They were bacterium. And so over time, we've just sort of decided that they need us and we need them. So it was a very, mutually beneficial relationship.
And so our DNA does not code for them, correct?
No, our DNA does now. So our nuclear DNA contains genes that code for proteins that are important to the mitochondria. So there's currently a two-way street going here. The mitochondria come from maternal line, so the mothers pass it along onto the children. Our cell with the nucleus and our own DNA has enveloped mitochondria, which has their own DNA, their circular DNA.
Which is what a bacteria has, is a circular ring
Exactly,
of DNA.
exactly. So they were, in evolutionary times, they were their own bacteria, their own species, but they needed us for nutrients, basically, for, substrates for their electron transport chain. So we gave them that and they gave us energy. I mean, obviously I'm making this very simplistic, but that is generally what has happened over the course of many, many, many years. And so they have their own DNA, but they became a lot more efficient and a lot more effective because they borrowed from us some of the proteins that we were able to produce for them. And so now you can have a mutation that results in a mitochondrial disease that comes from the nuclear DNA. So that first came on the scene because some of these mutations really do cause disease and cause obvious symptoms. I mean, things like seizures and, eye movement abnormalities and so on, and failure to thrive and developmental delays and myopathies. And so you would see this early in life. And so, at first it was sort of recognized in the pediatric world in terms of disease. And that still exists, obviously, and we're learning more and more about the different diseases that can come from mutations of either the mitochondrial DNA or the nuclear DNA that controls the mitochondria. But now we know so much about the mitochondria that we know that other things affect it in its dysfunction. So it may not be a disease in the conventional sense of a genetic disease in the conventional sense of a mutation, but it could be just sort of some, extra burden, extra oxidative stress that just sort of results in sort of a weakening of the enzyme complexes that can't control the amount of free radicals that are produced. I should say that oxidative phosphorylation on its own produces its own free radicals, but it also produces antioxidants. And so usually the mitochondria can sort of contain their own free radicals.
Like, take care of it yourself.
Right, exactly. I'm sure you have
there.
some great analogy for that, right? Like if you're producing your own. But what happens with all these burdens that we were talking about is that it ends up, there's too many free radicals. There's too much oxidative stress for the mitochondria alone to contain it. And so that's when it sort of starts to, weaken a little bit. And it can be repaired and it can be supported. And, early on, you can do it fairly easily. It's more chronic illness, which is what we see here in this clinic, that I think is a challenge, but certainly not, it's not an obstacle. It's not insurmountable. It's something that can be done. And there are various methods of which we do it. And we do the VASPER therapies. We do a lot of nutritional guidance, and we do herbal support and, vitamin kinds of guidance and
IV therapy,
IV
hyperbaric
therapies,
oxygen.
absolutely. And all these things can really help.
The analogy that I go back to is the difference between when people think about our genetics. It's so common to hear someone say, well, I have an MTHFR mutation, so I don't methylate my B12, or I don't do this, or I don't do that. But the truth is we're talking about the difference between the blueprint and the construction crew. And so mitochondrial disease that we see in pediatrics is really like errors of the blueprint that a construction crew kind of can't make up for. It's an unsupported wing of a house, and so the house just sags, and that's what we see. Versus those of us who make it to adulthood generally intact and then have mitochondrial dysfunction have a blueprint that's good enough to get us by. But now our construction crew has been so impacted by everything around them. There's too much noise, there's too much pollution. Really, it is noise. I just think about how many taps it is on our neuroendocrine immune system or psychoneuroimmunology, endocrinology, that it's like that construction crew is overwhelmed. And so then they build everything wrong. Things are upside down, inside out, and that's what we're working on fixing in adulthood.
I love your analogies. I can't come up with analogies. I try often, I try to sort of explain it on more simple terms for patients sometimes. Well, because what happens with dysfunctional mitochondria is that they have inefficient mitophagy, right? So they never really turn over. And, a cell, specifically like a neuron cell, which lasts forever, they don't have autophagy, which is what some of the cells in our body do. And so they can sort of control their turnover of mitochondria. But some cells don't really have very common autophagy or frequent autophagy, some barely at all. And so the mitochondria, they do mitophagy and they have their own machinery to sort of program that, but when they're failing, they're not very good at that either. So they just sort of hang on and linger around.
So the things that we're doing now, all these things bring in essentially and inspire new mitochondria.
Exactly. And that's what I find amazing, and that's been proven actually. It shows there are several mechanisms by which they transfer mitochondria, but the most common one that has been seen is the nanotubule formation, which we know this is a mechanism that's been known for a long time for transfer of other things between cells. That was just the most fascinating piece to me. I guess because I'm so interested in mitochondria and its science, that the thought of stem cells transferring new, unused mitochondria to cells that are struggling is just an incredible concept.
It's crazy that we have that kind of lodged away, that we do inside of us have closets, like closed closets with raw materials just hanging out.
I know.
If we do get sick, why doesn't our system go in and open them and be like, we need some of these and some of these?
Yeah, that's a really good question. I mean, I'm not sure. Obviously, that this whole idea is the whole reason why cord blood became so popular, to sort of bank cord blood, for the idea that, gosh forbid, your child gets sick somewhere in the future, at least you have their own stem cells, their embryonic stem cells.
Right, because a younger age is going to have a more potent, a more upstream stem
Right,
cell.
they're pluripotent, right? So as opposed to the stem cells that we contain as adults, they're more multipotent.
Yeah.
So it's just a next level of differentiation, though not differentiated yet, but just sort of the next level of just activation, I guess is a better word. But it's the whole reason why cord blood banking became so popular, because in case you were to need it later in life. But we still have that ability, and even the brain has the ability. We have neural progenitor cells, which are basically neural stem cells, and so we have that in certain parts of our brain, in the dentate gyrus. Some other parts as well, in like the subepidermal zone of the lateral ventricles. They contain neural progenitor cells. They are there in our brain to help make new brain cells, basically.
That's exactly what I was going to say.
These are just fascinating pieces of our own human ability to have like a healing power. It's like within us.
Yes.
And the idea to try to access it and use it is, I think, what a lot of researchers are really sort of, honing in on and trying to understand more of what we can do with our own cells.
in Ayurveda, out of the 8 branches of medicine, rejuvenation Rasayana is an entire branch. And it basically, I think part of what happens now is that we have these patterns that get us into trouble that overwhelm our mitochondria as well as our other cells. And we try to heal within that overwhelm. So we don't clear away the mechanisms that cause the confusion to begin with or the overwhelm, but we still try to heal within that. And Ayurveda, much of that science or that entire branch is really about clearing out that overwhelm and then clearing out those house guests, those bad house guests, and bringing in new things. So there's a whole science around that, and that's kind of where we're headed next in, the things that we want to do here.
I love how the Ayurvedic wisdom that you have and the Ayurvedic teachings, it parallels so much of what I know and what, I think neurology is about very often, and I think what we do here in the clinic. It's so fascinating to me, it really is. I think there's just sort of so much more to learn, though, so much more to know. And that's what excites us, I think, every day, right?
Yeah.
We always say we learn from our patients. And I think every patient teaches us something more, but also, importantly, it gives us more questions to go and try to answer.
Yes.
And that just helps the very next patient that we see. And that's sort of how I see it. It's just the chain. It's never ending. And I think it's rewarding and motivating.
I'm so curious about is where do we see consciousness in our mitochondria? Because they are at the head of the cell danger response. They have to make a decision, threat, safety or threat. Do I perceive a threat? We know that I'm putting threat in air quotes here because threat can mean so many different things.
Absolutely.
It can be physiological, psychological, all these pieces. And I think threat in our world right now is a real hot button because who is threatened by who, and with our racism and our social justice and our culture wars that we're having, so much of it is about a threat when a person feels threatened and when we agree that they feel threatened and when we agree that they should not feel threatened. And we see that very different we see that historically one way and we see that perceptually a different way, they don't necessarily align. All that to say, can you talk a little bit about consciousness in the mitochondria? Because that's, I think, where neurology has to go. We have to recognize the consciousness in our systems, that there is this invisible hand of the market that is moving our mitochondria. They perceive, there is sense there. What is that?
I do think they sense things, right? I think they sense things because, our body has a as much as we talk about consciousness, the truth is that our body has a physiological, biochemical reaction to threats, whether they're real or perceived or what have you, because they're real to the person. And I think one of the things that, can be done is to try to validate that threat. I think it's actually more stressful for a patient to feel, an individual, to feel that they have a threat, but others say that it's not a real threat, but it's real to them. And so I think the challenge there is really to understand where that threat comes from and maybe work through that. But my point is that when we feel threatened or unsafe or uncertain on any level, whether it's financial, whether it's physical, so any level, I guess, of stress that we perceive, whether real or not, but we feel it stress, we have a physiological and biochemical reaction to it. So there are changes that take place from that emotion. And those changes of all of those different biochemical mediators do have effects on our cells and on our mitochondria. So, whether that's consciousness of the mitochondria, I'm not so sure. We'd have to really define consciousness on some level but I do think it's a sensing by the mitochondria of something that's amiss amongst its environment, right? So, I think that's important. We have to recognize that. Yeah, and I think it's an interesting question, actually. And I wish we understood more about consciousness. There are, in neurology, we talk about disorders of consciousness. There are textbooks written about it.
Yeah.
Because consciousness is so elusive in so many different ways, right? So what does that really mean? What it means to you, for example, might mean something different to me. And I think that's something that we should actually explore.
And I think at the root, we're talking about sentience. We're talking about awareness.
Right.
Our mitochondria have sentience. They perceive and respond. That's the nature of the neurological system.
Absolutely.
As well as the immune system, as well as the endocrine system, the parasympathetic, sympathetic nervous systems are sensing and responding.
Right. We hear people say all the time that they, will have elevated heart rate and they'll feel like a little sweaty or, and that's the outward manifestation of something that's changing physiologically. And so without question, the mitochondria sense that. And that can just come from because you got scared, because someone came around the corner, quickly and you didn't expect them.
Yeah.
It could be as simple as that, which is transient and usually self-resolving and everything. Homeostasis is really very powerful, actually.
Yes.
So if the perceived threat or the stress is short-lived, then we just move on with our lives. Otherwise, I don't think it would be compatible with life, right? We all have to find some way of processing and dealing with any kind of, stressful event. But chronically over time is sort of what we're talking about, which is that, it can really take its toll over time, where homeostasis just has a harder job to get back there, and so you sort of inch your way along. You start at a balance, then you inch your way along till some point in your life you're so far off that midline of the scale, that keeps the two weights in balance.
Yeah. Then we're starting to talk about memory. If we have a memory of someone coming around a corner quickly and then we freak out. And so then the second time or the third time or the fourth time, we're more primed. So then even when we get to the corner before someone comes around, we're already responding as if somebody is about to.
That's exactly right. Right. So, and there's metabolic memory too. So when the cells perceive that kind of change, they hold that metabolic memory. That's part of actually what the cells will do. And so that response will be a lot quicker the next time. And sort of like you were saying, that people behave in a way like they've had that threat before. So they change their behaviors because of that previous experience. So I think that there's a physiologic parallel to that, is my point.
Do mitochondria do that, do you think? Do they have memory?
I think to some level they do. I think, again, the oxidative phosphorylation is just this machinery that's sort of trying to churn out energy to work that cell. And if that cell sort of, has that physiologic memory of what happens, at a particular point in time in which the signals come from our brain. So if we're perceiving something that, we had experienced before, then that brain sends that signal. And I think it's all interconnected is my point. Mm-hmm. So I do think that they, on some level, participate at least in that kind of memory.
That the immune system, the entire immune system has memory.
Oh, yeah, absolutely. We create antibodies which hold that memory of that particular organism that we were, assaulted by.
And we have names for them, right? IgG, IgM is current, IgG is old. We even have biomarkers where we essentially are measuring the memories of our immune system.
Right, exactly. So yes, so that the immune system is a perfect example of cells holding memory. That's what they do. In fact, they're called memory cells. It is a perfect example, though, to sort of prove that idea that cells do hold memory. And that's an obvious one where we were able to sort of, identify that easily because it had these antibodies that were primed for a particular antigen. But to think that other cells don't have that capability, I think, is not true. It probably is not as obvious, but I think it's there.
Some of our therapies here even focus on looking at what are the memories that we're holding and are those memories relevant or not. There was a time in our life when often for many of us when we're very young that we formulate memories, immune memories, neurological memories, these metabolic patterns based in memory when maybe things weren't so good or didn't go our way or we didn't have control over it, and resolving those in our new reality and our this moment reality is part of our work with every patient.
Yeah, absolutely.
We got to stay current.
Absolutely. And then even just the population in general gets more and more educated. I think the internet has provided access to a lot of different information. And so people just come in more educated, and that's definitely very helpful to us. So.
Yeah. When we are in chronic pain or we have chronic disease, do you want to talk a little bit about how the machinery breaks down? What happens in oxidative phosphorylation? Robert Navio talks about this in terms of going from power stations to battle stations. Yeah,
right. It just, the complexes just start to break down. And that's why I like to refer to it as a chain, right? Mm-hmm. So it's like it becomes a weak link. And so when one link isn't feeding the next link, then that link starts to suffer. Yeah. So it just sort of starts to break down into separate stations trying to sort of do its job, trying to compensate for the others. So, and that's what we think happens in chronic illness and chronic disease.
And that's why regenerative medicine is so relevant.
I think it's extremely relevant. Absolutely.
Yeah. Well, any last thoughts? We covered mitoswab, how do you test your mitochondria? We talked about the preventative foundations of health. We talked about how they break down when things go sideways, why they break down. And we talked about some really good mechanisms for getting them back on track. All right, perfect. Well, thank you, everybody, for tuning in today. If you have more questions, please do let us know. Thank you for listening with Dr. Ilene Ruhoy here. We've got lots of ways to continue the conversation through Facebook, Instagram, and Twitter, and you can also get more information from and about us at our website, centerforhealingneurology.com, or even better, come see us in person in our Seattle-based clinic. We are doing stem cells, Vasper, hyperbaric oxygen, IV therapy. We're doing it because we know that you're sick and you can't wait, so we are here for you. Please be sure to share this show with your friends, and we welcome your rating and review wherever you get your podcasts, and feel free to send topic requests to podcast@centerforhealingneurology.com. We love that you've joined us today to discuss how to make our whole world medicine. We rise or fall together, and we're committed to doing what we can to make as many of us as healthy as possible. And this takes all of us, including you. Thank you for listening, and see you next time.
Fish Media. Partyfish Media acknowledges that it operates and records on indigenous Duwamish and Puget Sound Coast Salish land that is still home to the Duwamish tribe. This land is stolen in violation of the Point Elliott Treaty of 1855. We are committed to uplifting the name of these lands and community members from these nations who reside alongside us. For more information on this land, its people, or ways you can help, visit duwamishtribe.org or realrentduwamish.org.